Alright, so this is the last video in the series of CI/CD tutorials that we have here. And honestly, at this point, there's not a lot left for you to do other than to talk about actually making a test for physics. So let's go ahead and look at what we need to do. So at this point, there's just a lot of code here to copy and paste. So we're going to go ahead through this last test, make a test for real section, and see what we need to do. So our first step here is to add a regression test. And so I've explained sort of in words what I need to do to myself. So I see here there's not a lot left. So let's go ahead and open our GitLab CI YAML file and see if we can implement all these changes. So it says here, I want to add a test stage after the plot stage. Let's do that. Next, we need to add a test job, test GGH. Test GGH, part of the test stage, and has the right dependencies. So obviously that's going to depend on plot GGH. And interesting, it looks like we want to grab the log file too. I wonder why. And in this case, we probably want to parse that log file because if you go back to some of the previous jobs that we've had here, where is it? The skimming job. Let's look at that for a second. You can see some of the output here is that it actually prints out some cut flow information. And that's useful information that we want to check again to check for physics or check for physics changes. And I guess our first attempt at this point, given this existing code we have, is to just check the log file has outputs that we expect it to, which is fine. Alright, so let's go ahead and add in the skim GGH dependency as well as the plot GGH dependency. Now that we've added the skim GGH dependency, we should go back to here to where skim GGH is, and we're gonna go ahead and dump that into a skim GGH.log file. And then we're gonna go ahead here and let's see here, add in the artifact, which is fine. And let's see here, we have histggh.root, we're good there. Okay, and it looks like we finished up everything we need to do in the YAML file, I think. Almost everything. So let's quit out of that for a second and make a test directory. In it, we need to create two Python files named test cutflow ggh.py. And what is the other one? Test plot ggh.py. And looks like these are going to use pyroot and pytest. And we've included some lines in the tutorial here that we can copy paste in. So let's go ahead and look at this. So here's test cutflow ggh.py, and this is a lot to type in. So I'm just going to go ahead and copy paste it in. And this looks like it's parsed in the log file that we create here, skimggh.log, and it's going to parse it line by line and check that the lines match. So that looks pretty good. It's just going to look for the fact that these lines exist in the file. That's pretty great. Alright, so I'm going to go ahead and add that test cutflow ggh. We're going to add that test because that test is done. Alright, we have a template for test plot ggh, and let's copy paste that in and talk about it. So this one looks like it's using root pyroot. It's going to open hist_ggh.root, is going to look for particular keys in that output histogram, particular histograms in this case. And if it can't find those histograms, it's going to exit 1, a failure. And then in this case, it's gonna integrate the GGH leading PT histogram here. And if the integral of that histogram varies too much from this value, this truth value that we know about, then we know that the physics has changed in that histogram. And that's an important thing to keep track of. And that means when the physics changes, we've identified some sort of regression. And that's a very good kind of test to have here. So that looks pretty good, and if it fails, it'll exit 1 and we're good to go there. Otherwise, the script will exit 0 by default. So we'll go ahead and add in that test. So we need to be able to run those tests. So the way we're going to do that, for example, is likely with just running Python, I believe. If we look at the test cut flow that we have here, it looks like we just run Python on it, right? I should just be able to, sorry, Python 3 test cut flow. Yeah, and it looks pretty good here. Alright, so, I'm gonna go ahead and make this work. So, it looks like this uses Python 3. I noticed this because of this print statement here, which uses a format string. So that should be pretty good. So, what else do we need to do here? Um, let's check this other test just to see what that looks like. The plotting also looks like it should just work out of the box as long as root exists. So yeah, all we need to have is root existing and we're good to go there. Alright, so we need to go back to our GitLab YAML file and we need to use the same root conda image that we've been using all along. I'll copy that in. Alright, and we need to write a script here that runs these tests for us. So we'll go ahead and do something like, say, Python 3 test. What are the file names? One of them is test cutflow ggh.py, and the other one is Python 3 test plot ggh.py. And let's see how that works. Alright, test plot, test cutflow. All good. We need to add the GitLab YAML. And then we can go ahead and see what the stage changes are. And things look correct. That adds the 2 new files. And it adds the test job. We're adding a test stage. And everything looks right. So things should just work. Add regression test. Or maybe add test on physics. And we'll push that and see how things go at this point. And now you can see that we have 4 stages now. We've got the build stage, we've got the run stage, we've got the plot stage, and we've got the test stage. Now I'm a little bit curious at the moment whether or not this root project image that we've been using had Python 3 on it. Hopefully I've been smart enough. So you know what? Why don't we try doing this? Docker run. Actually, you know what? You're gonna learn about Docker in a later session, so I won't talk about that for now. We're just gonna go ahead and patiently wait for all of this to finish up. The build stage already happened. Wow, that's fast. Perhaps the run stage will be fast too. So we're just waiting for this Docker image to pull right now. So we'll just wait and be patient. There are lots of different things that you can do at this point. You've understood a lot of the basic CI/CD features from pipelines, stages, jobs, being able to compile, being able to debug, being able to play around with the various different features of GitLab itself, being able to navigate. You've been able to, add environment variables to these things. And then you've been able to run Python code, been able to run compiled C code, and then use artifacts and pass things around from time to time. So that's been a lot that's been going on so far. So I think that's a pretty good use of time here. So let's see what happens in the next few jobs that come up. It looks like look at that. Sorry. It looks like skimggh.log was also created, which is great. So let's go ahead and look at the plotting and watch that go. So if you look at what we have here so far, we built this all from scratch in just basically, under 3 hours without too much of a pain. So the whole point is that it should be pretty easy to do everything you need to do for whatever you're looking at. Let's go ahead and look at what this test stage is doing now. I'm kind of half expecting it to fail at this point, and it does. And look at this. It's not able to find this line in the file. Integrated luminosity is 11467. And you'll see here that this log file is 114467. So it looks like we have a typo in that script. So this is in the test cutflow script, right? Where's the integrated? Right here. So we're gonna 114467. So let's update that line. So it failed, which is great, but we should go ahead and fix typo in Python in cutflow check. Let's stage commit push, and let's just do that all over again one more time, just to be sure that we've got everything going. Hopefully these will run a little bit faster, since at this point we should have hit enough runners that they've all cached this root project image for us. It looks like we've got a runner with a cache here, so it's hit this and it should run a little bit faster. How fast does it run? Let's see here. Alright, let's move over to the run, which should be running now. Yep. Things are running pretty fast, which is nice. Alright, let's move over to the plotting stage. Hitting a lot of runners with caches, so this is going to be one of the fastest pipelines we've had. It's always very nice when you can make a computer do everything for you. Alright, we're already on the test stage now. Let's see if this works. It failed. And you can see now that the integral of GGHPT1 is different. So it looks like the integral has changed a little bit. So maybe we should go ahead and fix it or understand why that happened. So it looks like I'm somehow off by a factor of 2 in this integral, a factor of 10 order of magnitude. That's probably somewhat expected depending on how many events I ran over. So for now, we're gonna go ahead and update this just to get the job working. But you can see it looks like the cut flow test passed, which is great. So we just need to get this one passing. Fix typo, maybe? Perhaps it's a typo. In the GGH PT1 integral. Let's go ahead and do this one last time to finish off this entire tutorial. So, at this point, now that we have everything in place, you can imagine that the next thing to do is to try to do the same thing for a project that you have in mind. A project that you already have existing but you don't have any CI for. Maybe you already have some CI implemented on a project you collaborate with other people on. And you can look at that, maybe figure out a way to refactor or improve or clean up in a way that you don't have to repeat yourself too much. There's lots of different ways you can do that. Or, sky's the limit at this point. There's a lot more that you can do with this, and we've only ever covered the basics here. Is the skin job running? I wonder what happened with build latest. Oh, maybe that's slower. Yeah, it looks like we hit a Docker runner here that's taking a little bit longer because it doesn't have a cache. Alright, should be any second now at this point. It usually takes about a minute 30 or so from what we've seen from experience when we hit a runner without a cache. Alright, so let's skip over to SkimGGH. Alright, and that's triggered and running now. That already hit a Docker, that already hit a runner with the cache. That's pretty fast. Look at that. It looks like it's going to be running in just under 30 seconds for this entire thing, maybe? I'm not sure. Definitely under a minute by this point. Oh yeah, look at that. 29 seconds. It's pretty fast. Alright, let's see what the plotting is doing. Man, CERN has so many shared runners, so it's just a bit of luck there. Hopefully you have better luck than I do some of these days. Let's be patient. Here we go. So, this is it. We're just about to see if our test job runs successfully. Let's jump over to that stage. Oh, we got lucky here. So, do we now get to finish everything completely? It looks like we do, and we do have a successful pipeline. And that means at this point, I'm happy, and we've been able to add CI to the project. I can go ahead, click edit here, remove this work in progress prefix. Oh, sure, yeah, I'll squash commits. We'll go ahead and save the changes. And this is ready to merge. So we click that shiny green button, which only shows us shiny green because the pipeline or the jobs in the last pipeline have passed. And we click merge. And with that, we are done with this tutorial section. Have a great day.